Good morning, everyone, and thanks for joining us. I'm Tyler Roach with Fuse Hub, and I am happy to bring you the 8th event in our Manufacturing Reimagined series. Crisis Workarounds, Alternate Materials, Product Redesign, and Remanufacturing. But before we get into all that, let's go over some technical tips and tricks that will be helpful while using Remo. First of all, welcome to Remo, our virtual event platform. You may have noticed Remo is very different from other online platforms. When you enter the event, you will be dropped into an open seat at one of the tables. To move tables, simply double-click on the table you want to join. If you're having trouble reading the table labels, you can pinch zoom on your laptop's trackpad, or if you have a mouse, scroll to zoom in. Additionally, you can click and hold on the white space between tables and drag the map around to get a better view of the conference floor. When moving tables, your camera and microphone may take a second to reconnect, so just be wary of that. You can also click on different avatar circles to see a person's name, contact information, and even send them a direct message. You'll also notice you have a toolbar along the bottom of your screen. You can use this to send messages to the general chat that everyone can see, or the table chat that just your table can see. Once in presentation mode, if you'd like to enlarge the presentation slides, do so by clicking the 4 arrows in the top right corner of the picture that you'd like to enlarge. To be able to see all the presenters again, just minimize the presentation by pressing the same 4 arrows in the top right of the picture. If you begin to experience any sort of technical issue, use the chat feature to express the problems that you are having, and one of our technical gurus will find you and help you. So now that we've discussed the technical side of things, I just want to make a quick mention that this program is sponsored by New York Manufacturing Extension Partnership, MEP, specifically to support small and medium-sized manufacturers with COVID response initiatives. In fact, there are 4 pillars in this program, all geared towards helping companies deal with COVID-related issues. The first is the Manufacturing Reimagine program, a series of virtual events like this one that provide training and one-on-one discussions to help manufacturers address COVID-related challenges, plus the opportunity to talk with our solutions experts about available resources and project funding to address those challenges. The other 3 programs, including PPE purchasing assistance, virtual assessments to help companies optimize operations, and reshoring and rebuilding supply chain initiatives, all of which you can find out about at the newyorkmep.org website. So for today's event, we're looking at how COVID has impacted hardware manufacturers, including things like supplier issues, changing market requirements, material shortages, or unplanned customer demand. And we will share some resources that can help you overcome these challenges. So we're honored today to have experts from 3 of New York's top institutions. They are each going to tell us about their organizations, what resources they offer to assist manufacturers, and how those can translate into solutions for companies in the extremely dynamic manufacturing landscape we're currently experiencing. First, we will hear from John Sinnott at Cornell. Next, we have Mike Thurston from Galisano Institute at RIT. And wrapping it up today will be Dan Walczyk from RPI. For today's agenda, each speaker will provide some background on what their organizations do and explain which types of projects might be beneficial in overcoming certain COVID-related challenges, along with providing some examples and case studies after that. We'll go back to the networking format where you can meet the speakers virtually and ask questions directly. And with that, I will turn it over to John Sinnott.
John, you're muted. There you go. Slides look good though.
Now, can you hear me?
Yes, yes. Very good.
All right, let's try that again. All right, good morning, everyone. My name is John Sinnott. I'm a manager here at the Cornell Center for Materials Research. Our industrial partnerships program is at Cornell University in Ithaca, New York. I want to thank Eric and Tyler and FuseHub for the opportunity to tell you about the CCMR and what we've been doing during the pandemic. And I hope at the end of this, you all have a better idea of how you might take advantage of some of the amazing resources available to you through the CCMR. So what is the CCMR? Well, it was established back in 1960. Its mission then, as it is now, is to enable and perform cutting-edge materials class, materials research. And the primary funding for the CCMR comes from the National Science Foundation in the form of a Materials Research, Science and Engineering Center grant. Most of the money we receive through the NSF goes to students and postdoctoral scientists who work in disciplinary research groups. And currently, the CCMR supports 3 of these IRGs. Our atomic membranes group works with what are essentially 2-dimensional materials, things like graphene, and they're trying to develop ways to bend and fold them to create 3D structures. The photonics materials group, they're developing new materials to control how light and matter interact at the nanoscale. And the spin manipulations group, they're working on ways to control electron spin, which has a variety of applications, including very high density, non-volatile magnetic random access memories. Our seed projects, they're devoted to the exploration of new ideas. These are the kind of high risk, potentially high return projects. They cover a broad range of topics from mimicking cartilage and tissue materials that can be 3D printed to studying atomic scale defects in diamonds that may one day lead to ultra high density storage devices. We also have this amazing collection of instruments managed by a dedicated full-time technical staff of 12. There's an educational outreach program that's focused on improving K-12 science education and increasing enthusiasm in K-12 students. And our industrial outreach group, which I'm part of, that fosters interactions between industry and the CCMR. So while the CCMR is funded primarily by the National Science Foundation, the Industrial Partnerships Group is funded entirely by Empire State Development's Division of Science. Whatever they may be facing. And we do that by, and ultimately create jobs. Now, our motto has always been any company, any challenge, but somehow it feels like we're barely being tested on this one at the moment. But we're and it means providing access to experts who are world-renowned in their field. It means maintaining access anywhere in the world. And it means providing matching funds to help move the challenge from problem to solution. So I'll share shared instruments and our technical staff in a moment, but I want to point out we have a very broad range of faculty experts, from veterinary and medical experts to physics, engineering, and chemistry. And the CCMR is here to help match you with faculty experts that are willing and interested in working with you to solve whatever challenge you may be having. To help lower the cost, We can provide matching money to help pay for project expenses. And if we don't have exactly the right match, we'll provide referrals to other technical resources at other academic institutions or businesses, which you'll hear more about later today. So since today's topic is about making the best of a bad situation, I want to share 2 quick examples from companies who have worked with the CCMR, who had a plan, they prepared, and they've pivoted their primary product focus to the fight against COVID-19. So Folio Water makes antimicrobial water filters, packaged as simple cone-shaped coffee filters that provide clean drinking water to some of the poorest people in the world. They came to the CCMR seeking a way of monitoring the amount and distribution of the antimicrobial silver particles deposited during production of their filter material. The CCMR matched them with a chemical engineer familiar with filters and fine particles. They began by analyzing the current product for silver particle composition and distribution, and then they investigated various techniques to find a simple, reliable method for measuring the silver uptake during the paper making process. The impact for the company was an optimized process for controlling the inputs during production, which resulted in an improved product efficacy, lifespan, and lowered the overall cost of the water filtered. Now, with a worldwide pandemic raging, Folio turned their attention to protecting healthcare facilities and workers against COVID-19. Folio Materials is incorporating a copper material into their paper products. Copper has been shown to be effective at inhibiting the spread of the coronavirus. And adding it to a paper makes it ideal for manufacturing things like masks. So Halamine has created HaloFilm, a rechargeable antimicrobial polymer film that extends the life of chlorine-based disinfectants. Halamine came to the CCMR seeking assistance in optimizing their polymer film. They were matched with a material scientist who had an expertise in thin polymer films to help them achieve their goal of a coating thickness and chlorination condition sufficient to sustain a 3-month reapplication frequency with sufficient chlorine to survive a 1-week recharge frequency. So once HaloFilm is sprayed onto a surface, any chlorinated cleaner can be applied on top. Without HaloFilm, the disinfectant lasts about an hour before it starts evaporating, allowing pathogens to take root and spread. But HaloFilm locks in the chlorine, keeping high-touch surfaces free of bacteria and viruses for up to a week. HaloFilm's potential for fighting COVID-19 in public and private spaces attracted the attention of the National Science Foundation, who awarded them over $250,000 from the COVID-19 Rapid Response Research Program to expedite their product development. And they got a separate award of $225,000 to help fight hospital-based infections related to COVID-19. So I have one more example, if you will, of making lemonade from lemons. We took advantage of the pause in our activity here at the CCMR to produce a short video that highlights our shared instruments and experts. So let's take a look. I hope you enjoy.
For over 60 years, the Cornell Center for Materials Research, or CCMR, has been a materials science and engineering powerhouse. The research and development conducted here are revolutionizing many industries. As COVID-19 transforms our daily lives, the CCMR continues to offer resources to manufacturers looking to adapt and thrive in this challenging environment. Thanks to careful planning and effective execution, we can assure you that our world-class facilities are prepared for your safety. Physical distancing measures and PPE requirements are in effect, from Duffield Hall and Bard Hall to the Clark PSB complex and throughout the Cornell campus. Companies face many issues right now. Access to experts and quality diagnostics should not be one of them. We are committed to providing access to the highest quality testing equipment, processing labs, and technical expertise. Even now, the CCMR continues to invest in new tools that will provide the ultimate in electron microscopy performance, leading the way to future breakthrough discoveries and next-generation products. From specialty coatings and medical devices to food processing and electronic sensors, the CCMR can help reactivate and grow your business during these troubling times. Send us your materials, and an expert staff member can help analyze the data. We look forward to discussing potential solutions and soon even hosting facility tours and training. Until then, the CCMR is here ready to help any company solve any challenge.
So thank you, everyone. I look forward to connecting with you either later today or by email. You can reach out to me or to Michelle Vanderwald, the director of the Industrial Partnerships Program here at the CCMR. Thank you.
Hi, this is Mike Thurston. Eric and Tyler, can you hear me okay?
Yep, you're all good.
Loud and clear.
Good, and we hear you fine.
Okay, so again, I'm Mike Thurston from the Center of Excellence in Advanced and Sustainable Manufacturing at RIT. We're one of the roughly 30 centers that are supported by Empire State Development to help companies with advanced technology, and our focus is on manufacturing technologies, as you can see. So we're located at the Golisano Institute for Sustainability at RIT. As I said, each of the roughly 30 centers have different technology area focuses. The focuses of our center is on sustainable product design and lifecycle engineering. So basically product design and development. On the manufacturing side, Industry 4.0 related manufacturing technologies, digital and smart manufacturing, for example. We do manufacturing process optimization and energy optimization. And one of the areas that our center has been active in for over 25 years is remanufacturing. And we also lead a Manufacturing USA Institute focused on recycling and remanufacturing. Just quickly to give you an idea of some of the kinds of work we do through the center. We've done work in developing new remanufacturing processes there. You see for Durst in the Rochester area, and for Caterpillar, who's very engaged in our Manufacturing USA Center. In the manufacturing process side, we've done new process technology development with Mark and Tubing, process efficiency type studies with Gunlock, worked with LISC on inspection technology, and we also do a lot of failure analysis. In the case of Alstom, that was a production problem that they were trying to nail down as opposed to a product design issue. On the digital manufacturing side, we've done some work with local companies here in developing electronic work instruction system. We do a lot of work with process monitoring, Internet of Things, particularly in the energy space, and then have kind of a broad design portfolio. We did a significant training program with Dresser Rand in sustainable design. We do a lot of computer-aided engineering support for companies that maybe don't have that internal capability. And we also work very closely with many companies in design for manufacturing and assembly. We're also part of the New York State NYSERDA funded MCore program, which works with startups. NextCore is one of the leads for that program in New York State. So we work with them on startup technology readiness and manufacturing readiness assessments. To kind of get back to the focus of the webinar today, FuseHub asked us to talk about some of the reshoring and supply chain challenges that might be related to COVID. So here are some areas that kind of fit with our background where we could help companies. If you have shortages of service parts, we can help you repair, remanufacture existing equipment or components. In some cases, if you don't have a supplier, you can't get supply of those parts, we may have to reverse engineer and then help you resource those. If you actually have shortages of production components, again, if there's something you're buying from a supplier, those can potentially be reverse engineered or redesigned and resourced as needed. So we can help with that, and also with qualifying new or alternative suppliers if you need help with that. In the case of, in some cases, we've seen companies where, you know, they're short of workers and are trying to meet production, or in other cases, there may be new opportunities that come along because one of your customers or potential customers is trying to onshore more production. So there may be opportunities that your current capacity can't meet. So we can help in that regard with reorganizing your manufacturing facility or your processes to make them more effective, or to generate better social distance as needed. And then also there are some advanced manufacturing technologies that may be helpful if you're trying to up your production or make your production more efficient to meet those demands. Specifically, I was asked to talk about remanufacturing and how remanufacturing can fit in. So I'm going to give you a little bit of background on remanufacturing for those that aren't familiar. This is based on a study that was done almost 10 years ago by the U.S. Trade Commission, looking at different sectors within the remanufacturing industry. So you can see remanufacturing is done across a very wide range of different product areas. So in remanufacturing, what we're looking to do is take a used or end-of-life product back, totally take it apart, repair components as needed, replace components as needed, and then put it back into service as a new part with an as new warranty and performance and quality. So that's the goal in remanufacturing. And you can see, you know, a lot of business to business work in heavy duty area, consumer work in automotive. You may be familiar with that. Not too much in consumer products, although that's growing. And there is quite a bit of electrical and electronic remanufacturing. So what's involved in remanufacturing? If you're not the original equipment manufacturer, often you have to reverse engineer parts. So there are third-party remanufacturers, for example, in automotive space, that make their whole business out of remanufacturing somebody else's products for service purposes. So reverse engineering is an important part of that, and that includes understanding functional characteristics, dimensional characteristics, and material characteristics to meet, again, the original specifications. When we look at the actual process, we typically will completely disassemble parts. Many of them may be contaminated, so we have to clean them, again, to like new condition. Parts that have wear or potentially fatigue, they have to be inspected to make sure they will be able to meet another life with the required quality requirements. And sometimes that leads to repair. We do quite a bit of work here in metal repair using additive type processes, resurfacing shafts, repairing cracks, things like that. And then finally, when the product is assembled and parts are finished, and again, it's sold more or less like a new product. Different process for electronics, but kind of follows similar steps. So where does remanufacturing kind of align with some of the COVID opportunities? Again, come back to some of the same ideas that I talked about before. If you're having trouble maintaining your equipment because you can't get service parts, there is an existing network of remanufacturers for things like motors, controllers, power supplies, typical industrial equipment that can help you with low volume quantities. It's the kind of business they do. And sometimes that kind of falls between a repair and a remanufacture, maybe a refurbishment, but they can get you back into operation. Here at RIT, we can help you connect with the people that can help you with your problem. We also have, as I mentioned, internal capability to do mechanical repair on mechanical components, repair of wear or cracks or things like that. Another area where remanufacturing may be able to help is it can provide a service option for your product. So if you're having trouble with service parts, again, because of supply chain, you can go to remanufacturing as an option for those service parts. That could be done internally, putting together your own remanufacturing line, or with a partner company that's currently a remanufacturer. For example, if you have controller boards that are a service item, there's a company we work with in Chicago that does a very large amount of circuit board remanufacturing for appliances, and they could potentially help with that. Remanufacturing is looked at for service because it offers a significant cost or price reduction for your customers. Also can be a means of localizing supply. If you're getting parts from overseas, you can actually get them remanufactured potentially locally. Finally, on the last item here, I add again, because many people have had to reorganize their office setups due to trying to maintain social distancing in the office or in a manufacturing facility, in areas of the manufacturing facility. There are several regional furniture remanufacturers, one very large one located in Albany that has done a lot of work in this area, and they can cost effectively reconfigure workstation layouts to help you meet kind of your distancing, or if you're trying to move from a low wall office arrangement to a high wall office arrangement, they can help you with that more cost effectively than starting with new furniture. So I just wanted to mention that as an option. And that's my presentation. I'll be available also at a table afterwards. And again, I talked about remanufacturing here because that was kind of what FuseHub asked about, but we can help in many other ways relative to design and manufacturing of your products. So stop and see me if you get a chance. Thanks.
Hi, everyone. My name is Dan Walczyk. I'm a professor of mechanical engineering and the director of the Manufacturing Innovation Center at Rensselaer Polytechnic Institute, which is in Troy, New York. I want to talk about minimizing the effects of pandemics and other national emergencies on product design and manufacturing via redesign. And when I talk about redesign, I'm talking not just about product design, I'm also talking about redesign of your manufacturing processes or system. So I want to thank Michael for a great talk on remanufacturing, which is a good segue to what I'm doing. And again, I represent the Manufacturing Innovation Rensselaer. We've been around for about 31 years now. So before I get into my talk, I just wanted to mention what the MIC does. We work with New York State companies, especially small and medium-sized companies and startups that need research and development help related to new manufacturing processes, new manufacturing assembly approaches, manufacturing automation, both hard and flexible. Let me define what that means. Hard means that you design the automation so it does exactly what you want and nothing else. Flexible would be something where, for example, you bring in a robot and it could be reconfigured or reprogrammed to do something else. We also look at industrial robotics, which is, some people call it soft automation. We also are part of the Advanced Robotics for Manufacturing Institute. We have a hub. And we also deal with manufacturing system design and implementation. And we actually have a CESMI, or Clean Energy Smart Manufacturing Innovation Institute hub. Okay, so let me jump into the topic. So what I'm going to do is give an overview of design and manufacturing. And just so everyone understands kind of my context, I'll talk about the supplier tier system. And then from my standpoint, based upon my years of experience in manufacturing and running this center, what are the effects of COVID or any national emergency? Because COVID is just what's happening now. But what effect does it have on design and manufacturing planning, product assembly, and also part and assembly manufacturing processes? And then for whatever it's worth, I'll give you my thoughts or my suggestions for how to minimize the adverse effects of these pandemics and other emergencies on manufacturing in general. So let's look at the product design and manufacturing process. You start out with engineering specifications, conceptual, then develop concepts, and then you get into detailed engineering. Are you doing engineering analysis, simulation of your design? Here's where you're figuring out what are the parts, what are the assembly embodiments, and then as you start prototyping, and testing, how do these parts and products react in the field, with the consumer? The result of that is part drawings, CAD models, and the bill of materials. So as you'll see, the detailed design is somewhat affected by COVID. With all of that data, you use product assembly, joining processes, and quality assurance to create products that people want to buy. And in the process, you're dealing with both custom fabricated components and vendor components. The custom fabricated components you can do internal or external. Internal meaning you make them in the plant. External meaning you bring them in from outside. And in both cases, you're dealing with both domestic and international supply chains or suppliers. In the case of internal, really you're just bringing in materials and making the components or sub-assemblies in-house. With external, you're bringing in finished parts or sub-assemblies to assemble into your final product. With vendor components, things like bearings and printed circuit boards and things like that, there's the same issue. You have domestic and international suppliers. So those constitute your supply chain. So in this next slide, I just want to talk a little bit about the supply chain tier system. So, the OEM is kind of the end of all these parts and assemblies. They assemble the product and they sell it. But, who exactly qualifies as an OEM. I mean, even your company, if you're a supplier for someone else, you still have your own supply chain. So tier one suppliers typically are supplying parts and assemblies to the large equipment manufacturers. They in turn have their own supply network where they get mostly parts, and those suppliers have domain specific knowledge of their parts. And oftentimes the OEM and the tier ones rely on their expertise, their engineering expertise. And then below that, you have suppliers for the tier two, which are primarily raw and close to raw materials. Okay, so let me talk about the effect of COVID or any emergency on the product design and manufacturing process. As everyone's seen, markets shrink either temporarily or semi-permanently. Temporarily meaning that you would expect the market to come back up when consumer demand increases. Semi-permanently, maybe there's maybe COVID's going to change certain markets on a permanent basis. Customer discovery, that's really the key to design, is less personal. There's also this need to be able to pivot with your product mix because of new market demand or new market trends. And your current products may not be viable in a post-COVID world. Some other effects include the design process is done virtually. This has always been a trend with design and engineering, but it's even accelerated with COVID. Virtual simulation becomes very important because you have perhaps a less chance to do prototyping, or the engineering team is spread out. Prototyping becomes disjointed. I can see it with companies, and I can also see it just with design classes at our school, where the engineer, the designer, actually may not make the prototype and be able to test it. So they have to rely on others to do that. And then engineers and designers, like I said, rely on technicians to perform product and component testing more so than before. So these are some of the effects. How about with product assembly? How's it affected by COVID? Well, you're seeing domestic workers, so people that work in plants, either sidelined or even eliminated due to illness, having COVID, or they're furloughed, or they're even laid off. And furloughed is the best option if you have to downsize production because you don't lose expertise. Laying off, you lose that expertise. Assembly lines have to be de-densified. It's kind of hard because they weren't designed that way. They were designed to be efficient and increase throughput and increase quality. But things are going to change. Workers are also required to wear various forms of PPE and other protective gear. What are some of the other effects on assembly? Well, company supply chain is adversely affected, obviously. As you can see to the right, that image of how coronavirus is affecting global supply chains, and it shows what's percentage of parts imported from China, for example. So it's very significant. And the reliance on international suppliers, which is already difficult because of language, cultural differences, import-export regulations, and distance, it becomes a real weak point in your supply chain. And primarily companies that rely on China, which is the main supplier for most manufacturers. What are some of the effects on part manufacturing? Well, like I mentioned before, domestic workers are either sidelined or eliminated. Manufacturing cells have to be de-densified. Again, it's hard because they weren't designed that way. Workers must wear various forms of PPE and protective gear again, and the entire material supply chain has been disrupted because of COVID. So let me offer some suggestions, and this is based again on my reading, my own experience, and just to put in a plug for the center, it really it represents what the center and other centers around the state, other New York assets might be able to do to help these manufacturers. So related to design and manufacturing process planning, companies really should improve their digital literacy and capabilities. For example, things like CAD, computer-aided engineering, simulation software, so that more design can be done remotely. Many companies, I think most companies use CAD, but they don't use CAE software, for example. This is, being able to do it remotely among these, this big diverse group of designers and engineers requires digital tools. You need to be able to shorten the product design and manufacturing cycle to become more nimble for necessary product pivots, which we've seen. For example, do it in weeks versus months. Consider internal part designs that can accept components from different vendors. So for example, maybe if you've designed a bearing mount that accepts a particular size bearing, can that bearing mount be redesigned so that in case that bearing manufacturer, which might be over in China, isn't able to supply, that you can relatively quickly start manufacturing your mount differently so it accepts another bearing size. It may seem like a intuitively obvious suggestion, but a lot of companies don't really think this way. Some other suggestions: don't base component selection just on price. Consider proximity to your plant, in other words, reshoring or nearshoring. What's the supply chain robustness? How robust is the supply chain if there's some kind of national emergency or international emergency? Consider part standardization. So avoid specialty components when at all possible. Seek commodity parts from multiple vendors instead of having a specialty component if possible. Consider creating multiple designs for the same component so that if there's some supply chain disruption, you can do a quick switch in design. So can you do different materials or processes? So for example, to the right, you can see two examples of a clamp that's used in, I think, material handling. The one on the left is made of sheet metal. The one on the right is made of plastic. They both have the same functionality. Same thing, a bearing mount. One to the left is made of plastic. The one to the right is made of cast metal. So can you come up with different options in case you lose a supplier? Also improve your 3D printing capabilities, which is always important. Have multiple processes in material selection. Let me make some suggestions for product assembly. If it's allowed by the unions, see if you can, you should cross-train workers for multiple jobs. First off, to increase their value to the company, and also allow for more production flexibility, especially when there's disruptions in supply chains and in product mix because of COVID or other emergencies. Consider semi-automation or flexible automation to address both temporary and permanent labor shortages. This has actually been a big, there's a lot, or actually I should say a lot of interest with companies that can't get the workers for a number of reasons. So they come to us and say, can you automate the process? Hire an automation expert to oversee movement in this direction. We can help, a university can help kind of demonstrate something, but to implement it internally, you really need that expertise. So someone with an electromechanical background. Retain your manufacturing expertise and capabilities in-house, even if outsourcing other times. A lot of companies are really seeing the damage of years of outsourcing, and they lose their expertise in how to make things. So they rely on their the supply chain, and we're seeing the effects of that. Avoid investing in hard automation unless product or the part is critical during national emergencies. When we do automation, we really suggest semi or flexible automation. Hard automation makes sense from an economics point of view when you're making a lot of parts. But you could see where it's really important, where you're trying to pump out lots of masks and lots of visors and things like that. Also, you want to establish supplier alternatives in different countries to avoid disruptions based on a single country source. For example, if you're relying on suppliers in China and there's bad relations between the two governments and there's a disruption there, it's better to have other countries that you can get suppliers from. Lastly, let me just make some suggestions related to part manufacturing. The pandemic has exacerbated the adverse effects of too much component and assembly outsourcing. So for non-commodity items, consider bringing the capabilities back in-house or reshoring. When you're talking about commodity items like screws and resistors and things like that, there's no reason to try to bring the manufacturing back in-house. But where things, where they are truly affected by supply chain disruptions, something to consider. Redesign your manufacturing cell layouts to space workers farther apart, because de-densification is going to be something we're dealing with all the time. And also, and I guess finally, create an emergency plan for disruptions in your supply chain for every single part that's outsourced in your bill of materials. Okay, so that's all for my talk. You can see my email and my phone in case you ever want to contact me about what our center does or need some help. So anyway, thank you very much, and I'm turning it back over to Mike. I'm sorry, to Tom.
Thanks, Dan. All right, so again, I'd like to thank Dan, Mike, and John for all their great presentations. As I mentioned at the start of the event, once we exit this presentation mode we're currently in, you will have a chance to network with any of the presenters or Eric or myself. And that's kind of where we'll do our Q&A portion of this event. So please check out some of the resource tables and some of the presentation people's tables, or just go ahead and network with each other. And there's one other thing I'd like to note before we head back to the conference floor. When the screen goes back to the floor plan layout, there will be a section at the bottom of your screen with various links to organizations we've mentioned. There will also be a link to request a Manufacturing Reimagined resource report. It's really simple form that you can submit if you're having a COVID-related issue and need help identifying funding or resources that can help. So definitely check out those links. And with that, thank you for attending, and I hope you stick around for some networking. Take care.